In this demonstration, I just want to show the debugging features that LabVIEW NXG has, and I'm just going to do that with this very simple factorial example that you've seen earlier in the posting. So we're calculating a factorial. Factorial 5, we know, should be 120, and so it is. But it's great to see something simple. You can really debug this quite easily, but when things get more complicated, there are some good features in LabVIEW NXG that allow you to investigate a bit more of what's going on. And one of the most interesting parts I find, particularly in respect to the execution model and seeing how LabVIEW NXG is executing the VI, is to actually highlight that execution. So this time, if I was to run it, and we've still got 5 as our starting value, but let's just change this to say 4, just so we get a different answer. When I run it this time, LabVIEW helpfully displays the values that are flowing along the data wires between the components, and actually shows the execution in progress. It slows the overall time down, so we have a chance to see that. And that's great because we can see the values as they go through, and if we can see here when we're calculating the factorial, and I'm not suggesting that this is a great example of an implementation, but it allows me to demonstrate the features here. We only run through this true case option when the starting value is greater than 1. So if we actually used 1 and still running with highlights of execution on, you can actually see that it will flip the diagram view to the right option according to the data that's coming in. Now that's great. We can see those values. Now obviously, you know, this is simple again, but and we're running this as one VI. Perhaps your VI that you're interested in is much further down a calling stack. What we can do is, as well as highlighting execution, we can actually get it to retain the wire values. So let's just have a look at that. And I'll turn that off so it runs a bit quicker. And on the panel, let's just try factorial of 6 this time. Come back. And when we run it, you can see that it runs pretty quickly. And when I hover over these wires, it will actually give us the last value of the data flow itself. So in this case, it's an unsigned 32-bit integer that had a value of 720. So the highlight execution and effectively remembering values is pretty useful to see what's going on within your application. But like most IDEs, environments that you can run your applications in, you can also set up breakpoints. So if we had a breakpoint on there, and you see we're here on the left hand side, we're in the debug view, and you see our breakpoint has appeared in this VI here. When I run this application now, you can see that it's paused, and you get a visual indication here as well, but it's paused. And now our options are very similar to any other IDE. You can step in, step over, step out. So if we step over that, we can either step over that and it will run to the end because it's we didn't actually ask it to step into the case statements. When we run it again, we can step over and we can step in. And just as you saw with the execution, highlighting the execution, it would flip the case statement to the right option. Depending on the data that goes in, we can step into the while loop and start stepping over. Now, if we wanted to see what's actually going on inside some of these embedded VIs here, we could also step in. And these ones here are you know, they're just doing what you would expect to see there. Obviously, if it's your own application, you have your own embedded VIs in there as sub VIs, then you could step in there and just continue the debugging session on on that VI as well. So let's just step over that one. We come to the end of it and back in again. And like anything, we can just resume back and it will run and finish. And we've got a same answer again. So this time let's change that to 5 so we get a different answer again. Just make sure that that's running. What we can also do is add what LabVIEW NXG calls probes. So if we add a probe onto this wire here, you can see that the value, and it's remembered the last value because we've told it to retain the wire values. So let's just turn that off. And this time when we run it, we can get an in-flight update of the value on that wire as data flows through it. So here we debug. Let's step over that, step into that, and step into this one. And as we step over, and we're about to pass data along probe 2, and that's changed its value to 20. And so on, and 60. So let's just play that through to the end. And you see the final value there of 120. So those features are really what's available to you in terms of the debugging itself, and I've actually found them very useful and I have to say sufficient for working out what's going on with the code. So again, I hope that was quite useful just to see some of that feature there as well.